Okay, so hey everyone, welcome to this week's workshop. My name is Ethan. I'll be going through some operating system command injections with everyone. First things first, though, we do have attendance. I'm going to drop the attendance link in chat. Essentially, what attendance will allow you to do is, as long as you attend about half of our workshops, you'll become a voting member, and it also just allows us to keep track of who goes where. And on top of that, I do have an announcement. Tomorrow, there's going to be, we're collaborating with Hack Your Learning, and there's going to be a free speaker series with Donovan Tyndall, and he'll be discussing his experience and views on cybersecurity. So if you're interested, there is a link in that in the announcement channel. And that's a registration link because registration is required. I did post the registration link in chat as well in case if anyone wants it. I'm also just gonna, sorry, I'm just gonna type labels so they're a bit easier to read. There it is. Cool. So I'll give you some time to fill out at least one form. And I just want to give a pretense for the workshop. We are going to be working with, we're going to be sending some requests from a web page over to a server, and I do have control over that server, and I will be monitoring those logs, and I will be able to see what you send over. So if there's, I would just highly recommend not to send any sensitive data over because I don't want to see it. I don't want to break your privacy in any way, shape, or form. So just as a heads up, when you're filling out a password or something, maybe just make a very weak one. Yeah. Anyways, I want to get started with how, in order to figure out how to perform command injections, I want to talk about how servers and users interact first. So within most server interaction systems, we usually have a client of a server or a user and the server itself. So a user would usually indicate, hey, I'm going to make this request to do this thing. In this case, the user is asking to store some of their data onto the server. They then take their data and send it over to the server, which will now work on the data and store it. And similarly, another request can be made so that the user can request certain data to be taken from the server. And usually this request now will have some sort of certain identifier to ensure that the data that they're pulling from is the one that they want. So the server can take that request, read it, and say, oh, well, I do have this data. Here it is. I'm going to give it back to you. Now, the question that we're interested in for today is, how can hackers or attackers or adversaries, however you'd like to say it, how can we abuse this system? Well, let us introduce a third party, the attacker. So, suppose the attacker wants to attack the user in this case. What they can do is they can tell a request to the server. It's like, hey, I have this data. I'm going to send it over, and I want you to save it. However, this data that they're sending over is malicious. So that gets sent over. The server will be like, okay, well, it's just data. I'm going to save it. But as soon as a user wants to retrieve the data, the server will find that malicious, could find that malicious data that the attacker sent over, and then send it back to the user, infecting said user. So this process is typically known as code injection. And this is where an attacker will add code in a way so that the malicious code is served to different clients. And code injections typically only attack the users of a server, not the server itself, though it could be a step in the process of attacking the server. Typically, code injection by itself will attack the user. And this is most commonly seen in cross-site scripting. Like there's a really insecure blog. I make a blog post that runs malicious JavaScript on it. Now, anyone who reads my blog post will be affected by that script. Now, on the other hand, we have command injection. So do you remember that another interaction that any user, including the attacker, can have with the server is to specify some sort of request that contains data which identifies the data they want to collect from the server. Well, an attacker in this case can send or can create such a request so that the request itself contains malicious data. And then when the server retrieves that data, it'll parse it, but because it's malicious, that's when the server gets infected itself. So once again, command injections will typically run malicious operations on the server itself and will attack the server directly. We've seen this in the past with SQL injections, assuming you went through the beginner workshops with us, and we'll be seeing it today in operating system command injections. So a little bit more on OS command injections, or I'll just be referring to them as command injections today. To achieve functionality, a lot of servers will like to use terminal commands. So let's say I want to double check if some service is up. So in the backend, I could write a ping, have my server process call the ping terminal command and say, okay, can I ping this server? And if it can, well, then it's up. It's also good for a lot of system administration things, just checking current server statuses. Well, the issue with this is that terminal commands are inherently modifiable because, well, the terminal is meant for user use. So especially in cases where there's a user input from like a web page that we're using, it's very common to see that, these terminal commands can be manipulated to our benefit. And lastly, if there is a command injection, the injected code will maintain the same privilege level as whoever started the server. Now, this could be, in a very hypothetical sense, I've never seen this myself, but there could be the case where a server operator or sysadmin might create an additional user whose only ability is to start and stop the server, and that's it. And in that case, we can't really do anything with OS command injections. However, most of the time, it's usually the system administrator or some at least regular user on the server that we can essentially impersonate as we perform these command injections. So I've been saying a lot about command injections. How do we actually perform them? Well, I'm going to go through, I'm going to send a link into the stream chat. Sorry, just give me a second. Okay, so if you can, please do connect to that link. Here, you'll connect to one of the web pages, and this will actually be a challenge. However, I just want you guys to explore, just look around, see what you can do with it. There is a flag, but I'll go into that later. I just want you guys to explore. So we can, yeah, so let's learn some more. Oh, sorry, I do see some, oh, that's not good. Wait, sorry, give me a second. Strange. Oh, yes. Sorry, I don't know why that says HTTP. My bad. Sorry about that, guys. That should definitely be HTTP. Yep. I made the server myself. I don't know how to use SSL certificates, so we're going to be stuck with HTTP today. Sorry about that. Okay, that's good to know moving forward, because that means I'm pretty sure all of the links, like I think Firefox automatically sets it to HTTPS when you copy it over. I'll just have to keep an eye out for that, I suppose. So, yeah. So as you guys are probably seeing, okay, yeah. So we can learn more as we consider the following. So as you guys can probably see, the webpage that you're currently connected to is one so that a user can request what's in a given file directory, and with that file directory specified, the server will say, oh, well, here's the information that's found. And it's specifically formatted in such a way. Now, we can pretty safely say that this system is command injectable, beyond the fact that I'm just telling you that it is. And the reason for that is that the server is using user input, because we're able to specify which path to use. Oh, I just realized that I forgot to put flakes into Orchid. That's fun. Yeah. Yeah, sorry about that. Gosh, it just connected to me right now. Sorry about that. Yeah, anyways. Yeah, I knew I was forgetting something. Oh, well. So we know that this web page is, or the server is likely command injectable because, well, it's using user input. And based off the output that we're getting, like the return value that we're getting, it's likely calling ls-tech-la. And it's using whatever we specify in the little form input as the argument. And what's especially nice about this is that the raw response from the command is being returned. This is not always the case. It could be formatted. It could not show up, period. However, and in those cases, it's still sometimes good to attempt such an attack. But in this case, we are getting the raw response, and that's especially nice. So with this, we can also consider some pseudocode as to how this server works. So once the server retrieves a request, it'll handle it by calling this handle request function, and then it'll take our inputs, which is going to be in the request body, and append it to some command. In this case, it's ls-tech-la. So once our input is added to the command, the server makes a system call, or sorry, an operating system call, a terminal call, to perform that command, and then it will write in the response what that returned, and then send it back to us. Now, onto the challenge. So within the page that I just sent you, there is a flag. This flag is the name of the user, name of a user on the server. So I'm just going to ask if you can take some time. I'll probably give you about 5 minutes. So actually, might as well round it up to, yeah, 5. And then we can come back at around 6:24. And if you do get stuck, do not worry. We're going to go a little bit further into this. I'll just put myself onto mute. Cool. Just wondering, it is 6:24. Would anyone like some more time to just mess around, or would you like to get into some learning? You can type it in chat, unmute yourself, whichever. Assuming I don't see anyone, I might continue. Or just, man, you guys are going ham on this server. It's pretty great. Cool. There will be another. There will be some more time to continue working on this. So if you didn't get it this time, there's another opportunity coming up. So, sorry, just gotta find myself. So, one potential solution will be this pattern here, which is colon and then who am I. Who am I is a very is a Linux command that's found on pretty much, I would say, every Linux distribution with an asterisk because I'm not 100% certain myself. But this it will tell us the current user who ran this process, and the most important part of it is the semicolon that comes before it. And what that indicates is that the previous command has finished, and this is a new command. If we enter that, we will see some response where we still see the lstack la command get run, and that's just because it doesn't need any it doesn't need any arguments to run. But at the very end, appended to our response is the flag, which is pretty nice. So why does this work in the first place? Well, let's consider the pseudocode once again. With the request body being semicolon, who am I, that gets appended to the end of lstack la. So with that, our command turns from just lstack la and then some argument to lstack a semicolon, who am I. And because of that semicolon, it's going to say, we're going to run lstack la and who am I. So when we make that call, we're calling lstack la who am I as two separate commands. And they're both valid commands. So it's going to return basically that entire call, so both command calls, and then write that into our response and return it. So now with this, maybe new command or technique, definitely try it for yourself. I'm probably not going to give as long this time. I'll probably just give maybe 3 minutes. So I'll talk to you back at 6:30. To whoever said hi in the logs, hello. Cool. Really quick, I'm going to be moving on. Just as a heads up, these servers are going to be up for the rest of, until this Friday. So, and that includes this challenge and all upcoming challenges. So if you didn't get it here, no worries. You can try again a bit later. I'm going somewhere with this. Yeah, it's just mostly the fact that the server is going to be up for from today to Friday. So I'm just going to give a quick demo. Here, let me get my page open. Oh. Here we are. I'm just going to connect to the page. So as specified, oh, it is a bit tiny. I'm just going to increase it. As long as we just do, who am I? Just enter basically the solution that was given. We'll see that the return value for ls-tac-la is returned. We can see my Docker file. We can see how the server is being run and some package stuff. And then also the flag that we're looking for, which is pretty great. Not for this, I guess not for the system admin, but it's good for us. I guess if you really wanted to, you can also just mess around. You can pretty much run any command through this, which is definitely not good for the system. But hey, it's good for us. So, I guess the next question would be what happens if there's some security in the way? And the main focus that we're going right now, we're going to be dealing with input sanitation. So certain server developers might implement input sanitation at several levels of the stack, or in general, just like in the system of dealing with your browser, which is the front end, or the server, which is the back end. So with front end, typically input checking is done through JavaScript or PHP. It can, depending on the implementation, it can completely block the possibility of making requests with improper inputs, but it's also one of the easier ones to bypass. On the other hand, we have backend sanitization. And although it might be a little bit more difficult for a developer to integrate these checks, it's definitely, for a developer, it definitely pays off because it could make OS command injections completely impossible, or make it very difficult to do. And in these situations, there's going to be some forensics that are required. So we can get started with front-end sanitization. So I'm going to be sending another link. This time it is actually HTTP and not HTTPS. So you guys should be able to connect right away. So I'll just give you guys a couple of moments to connect to the page. Let me know if it's not working, because if it's not, then that's not good. It should be up though. Cool. So while you guys explore, I'm just going to go through and talk about what this page has. As you guys can probably see, this web page is allowing us as a user to ping other servers. So yeah, I had some fun time developing some dark mode stuff. Hope you guys enjoy. Anyways, if you can ping, basically it'll ping whichever IP that you specify in the user input, that IP, and then return, again, a very similar output to to the terminal ping terminal command. So we can consider the pseudocode once again. It's very similar to our ls-tag LA example. However, in this case, we're just switching that command out for ping. However, if you do some sneaking around, you'd be able to find some additional JavaScript within this page. And this JavaScript is, I don't remember if it's called make request specifically. However, it's making sure that the input that we're entering into the web page is an IPv4 address, and what that is essentially a IP standard which uses 32 bits. It essentially, when the links that I've been posting, which is like 147.182.173.214, that's the IP address of the server. Every system on the internet has one. However, if we enter anything else that doesn't fit within this IPv4 pattern, like if the web page sees our input and says, oh, well, you have the letter A in there, that's not a part of the IPv4 pattern. It will completely reject the request. Now, there are still situations where even though there's the regular expression or string pattern checking is still there, it might be malformed or improperly made. In this case, which that just means that there are situations where it's only partially looking for it and it's not very strict. So if you have a proper IP in there and then just do the semicolon, who am I, once again, that would allow, the JavaScript would allow that request to be made because the IPv4 address is still found in there. So if you're trying to consider how to bypass this, you might consider disabling JavaScript. And that could work in certain situations. However, if we go back to the make request code, we see that at the very bottom under this otherwise comment, it's JavaScript is making a call to this fetch command. And what that does is the JavaScript itself makes the request for the user, not so it overrode default the default system to make requests. So in this case, if we turn off JavaScript, then this fetch command will never run, and therefore the request that we're trying to make will never occur. So I just presented a whole bunch of problems, but my question is, how can we bypass this? I'm going to give you guys about 5 minutes. The flag to this challenge is found within the root within the root folder. It's just within a file. We're going to talk about this a little bit more after this. So if you don't get it here, that's perfectly okay. Yeah, so I'll talk to you guys probably around 6:44. I should specify the root folder is not going to be the root user folder, so it's not going to be in a /root. It's just in /, just to specify. Okay, cool. Would anyone like some more time to experiment before we get into? We're not getting into the solution quite yet. I'm going to be describing a potential way of how to, like a few tools that you can use to help crack this. But I was just wondering if anyone wants to just continue exploring. If not, don't type in anything. I think based off the lack of replies I'm getting, I'm just going to move on. So here's the current issue that we're facing. If we add something like colon who am I to our response, like even if there's a proper IP, the server is completely preventing it from making a request. So only requests with valid input are being made. So there's two ways to work around this. Either A, we can use Mozilla Firefox's developer tools, because they have a pretty good one built right in, or we can also use CURL requests, which is a terminal, like a Linux command. We can do that on our end, and we can basically bypass these filters altogether. So let's quickly focus on developer tools really quick. To go into to access your developer tools, what you can do is you can right-click on any web page and typically find the inspect or inspect element option. Click on that, and you'll have a window that pops up. Alternatively, you could also press F12, and the same window will pop up. I was messing around with it today. You can also do Control-Shift-C. I just found that out. But in all cases, the developer tools window will pop up, and then you can go over to the network tab. It's just one of the tabs where it says, I think it's inspect, and then console, and a few others. If you don't see it right away, it could be hidden. There's two little like arrows pointing to the right. If you click on that, you would have a drop down menu that might contain network, if you don't already see it. And basically what this tool does is it shows all network activity that comes in and out of your browser, and it's typically very useful, even outside of this workshop. It's good for monitoring what your page is doing, and in our case, we can use it to bypass some JavaScript. So to do so, once we're all in the network tab, what you can do is right-click on a successful request. So let's say you're messing around, you type in 8.8.8.8 as your input, send it, it works, cool. Now that's a valid request. We can right-click on it, or sorry, really quick, if you don't see it, just make a new request, and then it should pop up there. So once we have a valid request there, we can select it by right-clicking on it, and then click on the edit and resend option of that drop-down menu. I hope these slides aren't too tiny. I'm trying to fit like 4 images in here, but there's going to be an edit and resend option that you can click on, which will open up a new window with a whole bunch of text and stuff on it. But the most important thing that we want is at the very bottom, it will say what the request body is. And in our case, we know from the pseudocode that our input is found within the request body. And then with that, we can also, once we modify the request body, we can go back up and then click on send, and that would make a new request with whatever we need, with whatever we put into this request. And I'll send it as if it was a new, completely separate request. Alternatively, we could use CURL or curl. What curl is again, a terminal command that's found on, again, every, with an asterisk, Linux distribution. And it's, again, useful inside of this workshop and outside of it. But, oh, sorry. So generally, a curl command would look like this, where curl is the command itself. TACX post would be, in this case, specifying an HTTP request method, which basically just tells the server, it's like, hey, this is how the data is going to be roughly sent to the server. And then, of course, the URL or IP of the server that we're sending requests to. So a more complicated curl command could look like this. So we have like this TAC-H option. We have this TAC-X, TAC-D. So what are these? Well, like I mentioned, TAC-X specifies the HTTP request method to use. Potential request methods are get, post, options, put. There's quite a few. But the most common two are going to be get and post. And moving forward, all of the arguments that we're going to be using is just going to be in the format of the argument itself, so TAC-X in this case, then a space, and then whichever option or value we're specifying, in this case, post. So along with this, we also have, in this case, the TAC-D option, which allows us to specify data to send over to the server. So in this case, we're going to be sending like this foobar string over to the server, and this foobar string is going to be placed in something called the request body. And it's important to note that whenever you use the TAC-D option, it's going to automatically set the request method to post. You can override this by specifying TAC-X if you really need it. It's just, in most cases, and by, I believe, HTTP standards, if there's data, it'll be using the it'll be using the post request method. Also in this command, we also see this TAC-H option. So TAC-H allows you to specify or modify the headers to your request. And what headers are essentially information about your request to inform a server about, like, how is this request being made? Who is it being sent from? What is the size of the request? And other information. And for TAC-H, the value, like whatever you're setting the header to be, you can do so by specifying it in a key value pair separated by a colon. So in this case, we're doing content type. So we're specifying what we're sending over, like what type of data we're sending over, and we're sending over a JSON file, which is application/JSON. If you want to do multiple, like modify multiple headers, you would have to type TAC-H multiple times per header to modify. And one last thing is that it's important to know that in HTTP standard, it's actually not required to it's not required to be worried about casing. So every header is case insensitive. Another one that is important to notice is the TAC-F option. Essentially, this will mimic something called a form data object. And it pretends that the data that you specify was placed in an HTML form. So if you go into like Google Forms to fill out attendance, for example, that's an HTML form. And if there wasn't like additional JavaScript or anything built into it, to fulfill that request, a request with form data will be sent, and it's just a special version of data. And once again, because TACF is just a modified version of TACD, essentially. So it would again specify to use a post request unless otherwise specified, and it'll place the information that we're sending into the request body. The nice thing about TACF, though, is that we're also able to send files through it, or any data, really. If we see here, this little @ symbol, it's going to specify that we're going to send the file at this path over to the server. It's pretty fun if you want to, I don't know, transfer files that way. But yeah, just so you know, form data does require a very specific response to it. Like, it requires a very specific way to handle it. So form data is generally, it might not be useful everywhere. The last, if my slides are going to change, there it is. The last argument that we're going to be looking at is the TACV, or verbose option. And essentially, it's just going to provide us information about how does curl perform the request, all intermediate steps and additional information. It'll kind of show us like, oh, well, I'm performing this TCP handshake, and it's just additional information about the request that you're making, which might allow you to enumerate a server or just see the progress of the request that you made. So one last thing is that you can use developer tools and curl simultaneously. So after specifying, or after making a correct request, you can go over to the networks tool in DevTools, right-click on it, and then actually copy the request that you made from Firefox or Google Chrome, or most modern browsers, I believe, and you can copy it as a curl command. In the ones that I mentioned, Chrome and Firefox, you can copy it as a Windows command or a POSIX command or a Unix one. And the only difference there is just how strings are being handled. But if you copy that over, you can put it into your terminal, and then you would have a curl command that mimics your browser, which is amazing. I think I have to give special props to Josh Novak for pointing this out to me. Just thank you, Josh. So now in both methods, we're actually able to modify the request body without any checks whatsoever. And the reason why it works is because it's not going through the website. There's no JavaScript checking it. It's just going regardless of the input that we're sending in. So after this pretty long preamble, maybe take some time to try it, mess around with DevTools, mess around with curl, see if you can get the flag. Again, it's in the root, so / folder of the server. So I'm going to give maybe, I'll give about 5 minutes again, and then I'll talk to you at 7:03. Also, if you can't get it this time, I will be also demoing it in a little bit, so just as a heads up. Cool. So it is 7:03, at least on my machine. Is there anyone who wants to just take some more time to crack at this? I'm going to take silence as a no. So, here. So, here's how to perform a potential solution. So, within the request body, because we can put anything we want in it, and it will be a valid request, we can specify that a command after, again, putting the semicolon to separate the ping command and the lstack LA. So we're just going to put in lstack LA / because we know that the flag is going to be in the root folder. Sending this will give us a second listed request within our network tab, and clicking on that, we get this admittedly pretty ugly response. It's just a string giving us our ping information, and then pretty much what we expect to see in the root folder, like the var folder at the very end, or if you go back, you can kind of see the user folder. It's not very clean, but it's certainly there. And what's even worse about it is that there's this a little ellipses here between this RO and OOT. That just indicates that Firefox is trying to clean up our response for us and actually shorten the string. So if we toggle the top right where it says raw, it will stretch everything out, and we have to go through it and scrub it. And if we take a look at it, we'll see that flag.txt is found within the root folder. I remember when I was taking this screenshot, it was not fun looking for this. It's doable, but it's not ideal. Alternatively, we could also use a similar command a similar injection with curl, and then we'll just specify an IP and then put the semicolon, and then place our command in there, and then send it over to our server. And that's just getting command injections into there. That's not the full process on how to get the flag, but I'm here to demo, so let's do that real quick. So, I'm gonna have to switch over to the correct page. So give me a second, sorry. Copy link. Cool. So once again, we have this admin panel. I'm just gonna ping the 8.8.8.8, and if you're wondering, that is actually the Google DNS IP address, I'm pretty sure. Yeah, so pinging that, we see that, okay, our server is able to ping it just fine. Cool. Let's try to inject something into it. Who am I? Well, that's not good. However, we can go over to, we already know what's causing it, so I'm just going to go over to the networks tab. Oh, it's probably a bit small. I'm just going to crank the size up a bit. Again, we can, this is a bit messy with a larger screen, but we can modify this by clicking edit and resend, and then doing the process as I showed earlier. I'm actually going to go and use curl. So if we go over to where the JavaScript is, which is in the debugger, I'm going to go into app.js and realize this is really messy. We see the JavaScript that we're using. And if we scroll down, we see the fetch command being made, and that's just being sent to our current IP, like the current web page IP at this address. So I'm just going to copy that real quick. And then I'm going to actually open up a terminal. And I hope this is large enough. I'm just going to crank it up. I'm going to specify curl. Looking back at the JavaScript, we're sending a post method. So I'm going to specify post, as post. We're also sending data, and if we take a look at set data, it's this val, so it's going to be the value of our inputs, which is just a regular string. So what we can do is 8.8.8.8, those are commas, whoops. Enter our semicolon, enter our injection, and then add our URL. So I'm just going to append it here because it's a little bit easier to copy. So this is what the curl command's looking at like right now. So sending this over, just got to wait for the ping command to finish, and boom, we have the response. We can see here that the flag.txt is found within the root folder. Also, if you want to clean this up, I like to use a Python tool known as json.tools. You can, if you pipe it into json.tool, I think it's going to spend some time. It's not going to really help out here, but if the response is a JSON, it's going to automatically format it. So it's just the key and value of the JSON. It just makes it a little bit nicer to read. It doesn't really clean up this, but oh well. And knowing that the flag, sorry, I got to search for it. I'm actually going to use grep because grep is amazing. Grep flag.txt. There it is. Now that we know that flag.txt is in there, I'm going to modify the request so that we're reading said flag. So let's just do cat and flag.txt. Just got to wait for the ping to finish. And then we have our ping information, but then also our flag. Cool. I'm just going to clear the screen real quick. Okay, cool. Let me switch over to the slides. So that's front end. How about back end? I have a new page for you guys to go to. Again, this is another challenge, just like before. Just take some time to mess around with it. Sorry, just typing it out. Again, HTTP, not HTTPS. So hopefully we don't get screwed over by SSL certificates. Well, while you guys are exploring that, actually, I'm just going to double check people are getting in. Okay, cool. So as you guys can probably see, it's a very similar website. Probably bad design on my part, but the title is different. So hey, at least we know we're in a different website. So the server functionality is the same as last time. We're specifying some server or IP address to ping. Cool. And then the server is returning that value. Also cool. Now, as this is the backend section of the workshop, the server is checking for user input on the backend. So if it finds an injection, then it's going to stop itself before it makes the terminal call, and then return an error in our case. So this is not always the case. Like this, sorry. The severity or the strictness of these backend checks will vary from server to server. Typically, to make sure that a server can be iterated upon and useful within future iterations, let's say I want to specify an IPv6 IP instead of along with an IPv4. If we use a very strict input check, well, then in that case, we run into the issue that we have to take down the first of all, add in our IPv6 check, and then take down the server, and then subsequently redeploy that server, which might cost a fair amount because the server goes down, and it's just a lot of overhead. So it's it in that case, it might be a bit trickier for a developer to figure out one single pattern to look for, like one specific pattern. However, if it is the case where they're strictly checking, we only want IPv4 IP addresses, well, this is one of those cases where it prevents us from doing any OS command injections, unfortunately. So let's actually take a look at the pseudocode for this server. So again, we have the same handle request method, and it's, again, appending whatever we have in our input to a command and then calling said command in the terminal and returning whatever value. But before it does all of that, there's this dangerous input function that's being called. And this can be implemented in a few ways. So, as previously mentioned, this dangerous input could just strictly check for a very specific input, in this case IPv4. If it's only like, well, if I see any other character that goes beyond IPv4 standards, it's not valid. Again, it is pretty restrictive for a developer who might come along and it's like, hey, we want to support IPv6. That's too bad for the developer, but hey, it prevents OS command injections altogether, which it depends on the server. It might be beneficial. But to maintain a level of modularity, or I guess future-proofing your code, instead, we can look for specific patterns that might invoke command injection instead. So in this case, this dangerous input function is just checking for general Linux commands. So ls who am I curl. If it finds that any of those commands inside the input, well, we know that there's most likely injection happening. So in that case, in that certain case, we can return to the user and say, hey, that's a bad command. Don't use it. So with this in mind, maybe take some time to experiment. Again, kind of playing into how similar this challenge and the previous challenges are, the flag is in the root directory, so / directory of the server. It will be, again, in a very similar format. Just take some time, maybe mess around, see what you can get out of it. I'll be back probably in 5 minutes. Oh, I'll be still here, but I'll be back to talk to you guys in about 5 minutes. So I'll give it till 7:22. Hey, um, I hope you guys are maybe getting a bit stuck on this, maybe not. Looking at the logs, I certainly learned quite a few Linux commands today, which is always fun. However, moving on, is there anyone who would like some more time to explore before we get into potential ways on breaking this, or are we all good? Cool. I'm going to take silence as a no. So, let us move on. So, oh, sorry. Yeah, no, for sure. Go ahead. I'm going to probably give another 3 minutes. So 7:25 would work. Do know that after our explanation, there's I'm going to be demoing it. Sorry, yeah. After the explanation of tools, there's going to be some more time to apply those tools. Just as a heads up. But I'll give another few minutes, 7:25, and then I'll be back. I see some really cool things coming through. Just want to double check. Would anyone like some more time? If so, you can just throw, I guess, the character Y into the stream chat, speak up, whichever. If not, I might just move on. Man, I'm seeing some pretty cool things coming through the coming through the logs right now. Very happy. I can talk about it after the workshop, because there's just a lot of things that I didn't consider. if you're wondering and not looking at chat, Kyle was just asking why are the logs so interesting, and it's just kind of there's things that I didn't consider, but you guys definitely have. So I probably won't be adding it to the recording because I'm recording this, but I will probably stay after for maybe like a few minutes just to say what's happening. Anyways, here's the issue that we're currently facing. If we can't perform a command injection if the server looks for that command, right? Like we have to put like ls if we want to run ls, right? Well, that's not necessarily the case. So let's consider we're trying to inject the command who am I. Going back to basics. Within the pseudocode, it was we saw that the server just went through a list of commands, included who am I, and checked if our input has it. And if it did find it, well, it prevented the server from running said command. But what we can use to our advantage is code obfuscation. So there's two ways of doing it. There's two ways of doing it. We can either encode or slice whatever we're trying to do. And what obfuscation generally is just a method to make code look really hard to read from a human's perspective, and is typically done to prevent reverse engineering of like a video game to prevent hackers, or government software to prevent hackers. Also to protect IP, like intellectual properties in terms of IP, not like internet protocol addresses. So let's focus on encoding injection first. So essentially what encoding is that we're able, it takes an input, it takes some input, messes it up in some relatively unreadable way, and then it's done in a way so that however we messed it up, it can be reversed. So when we want to, this might include like base64, this might include anything that you learn in, I think it's computer science 413, that's cryptography. I don't remember. However, 418, cool, thank you. Yeah, basically anything there. I actually haven't taken the course yet, so I'm not 100% sure. But that would include like Caesar ciphers. I don't think you can put pig Latin in there. It might be a bit hard to programmatically reverse that. But anyways, if we want to encode injection, here's what we need to do. We firstly, need to encode the injection. And then afterwards, we send that encoding over to the server. And then once that encoded injection is in the server, we have to decode it. And then lastly, run the decoded string as a command. So how do we do this? Well, one such injection for this would be this kind of messy input in front of you. So if you were to run this in your terminal, you would see that who am I is actually run. Like if you just put in this full thing, you might have to ignore the semicolon. You'll see that is it 419? Again, I'm not sure. I haven't taken the class yet. Pretty sure I saw 2 for 418. So sorry, Jeremy. I think through the rules of democracy, it might be 418. Oh, sorry. Okay, ignore me. I'm getting distracted. So in this case, we have our encoded command, which is IMAO HW, or who am I backwards. And that's being placed into this rev command. Essentially, it looks kind of messy, but what rev does is it's a command that's found on, again, every, with an asterisk, all Linux distributions. And what it does is that it would reverse the order of characters within a string that comes in through standard input. So if we just echo IMOHW into rev using this pipe, which is this little skinny line before rev, it will reverse it and it'll print the string who am I. Cool. We have our command in there, but what are the fancy like wrapping brackets around here? We haven't seen it before. What these are command substitution. Like this indicates command substitution. So essentially it will evaluate whatever is inside the brackets first, and then whatever is returned from that, it will treat it as if it was a command. And then because it's treating it as a command, we're running who am I, which is pretty great. So we can visualize this. So again, we have our encoded string or encoded command, which is IMAO-HW. When that gets reversed, it's turning into who am I, but this is a string, not a command quite yet. But with the use of command substitution, we're converting that string into a command. And then this command is getting executed. There's many commands out there that you can use. Like I was mentioning before, to encode your commands, base64, string rotations using the tr command. There's so many that literally I just went on the Stack Overflow and just searched up one-line string encoding and decoding things, like how to decode a base64 string in one Linux line. That's what I did. And yep. There might be the chance that the command substitution, like brackets, might be detected by the server and then would prevent it from happening. The next best thing to do in that case is using the backtick, which is on the same key as the tilde key. It's to the left of the one key, in this case without the shift. And it performs essentially the same way. Like super old versions of Linux, I believe, don't have this functionality, but I'm pretty sure most Linux distributions would be using it. So you can try that. And the reason why this works is because there's a lot of ways to decode or encode a string. Like if you were to consider, even with like a list of 5 commands that we're checking for, like let's say who am I, ls, cat, ps. I'm having a hard time listing a 5th one. I don't know. stdin, I don't know why. Between those 5, we already have, well, we've already mentioned reversing the string. That would take our list of 5 commands and make it into 10. And then we also have encoding it in base64. So that would take our list of now, I guess, 10 strings, or 10 things, because you can technically, you can chain encodings as well. So it would take our list of 10 things, make that into 20, and then with technically 25 possible rotations, there's a lot of potential ways, and it's going to be impossible for a server admin to go through every single type of potential encoding under the sun and check for all of them. I guess I shouldn't say it's impossible, but it certainly would be very, very tedious. Alternatively, we can also slice the injection. I saw some people doing it, and I'm very, very happy to see it. But essentially, we're taking our command and breaking it into separate parts. So to do this, we would take, like I mentioned, take the command and separate into parts, but parts in a way so that it's probably not identifiable by like input checking. And I'll go into what I mean by that a little bit later. But once we split our command into different parts, we have to make sure that all the parts are accessible within the server itself. So just storing them somewhere inside the server, maybe in memory, maybe in storage. I'm not 100% sure if you can do like place them into storage, but as long as they're on the server, we can probably run them. After that, we can take all of those parts, put them back together, and then like before, we have to execute the command as soon as we put them back. So this is a sample. This, again, will perform a who am I command call if you do run it. And this is kind of where we see what I meant by like unidentifiable, because if you look at like certain Linux commands, we're splitting who am I into WH and OAMI. The reason why I'm doing it specifically this way is because WHO is a Linux command on its own, and W is a command line on its own, or command on its own, sorry. So we're just going to split that into separate parts, but we're storing them into Linux environment variables, which are going to be test1 and test2. To gather the values of these, variables, we use the $. And what we can do here is place them into a third string or third variable, test3, and then run it as a command just by putting the terminal or the $, right in front of that. So just breaking down how this works, we're just storing test1. Storing WH into test1 and OAMI into test2, making them equal to that value. And then with this little string concatenation pattern where it's like $, test1, $test2, that's getting those values. And then it'll store the string who am I, like the combined string, into test3. And then with the $, test3 at the very end, we're calling the string as a command. It's a little, I think I visualized it better than described it, but essentially, we take the broken parts, slap them together, treat it as a command, and now we have a working command. There's a few issues that might arise with both of these injection methods. And this, I originally thought it would happen for some and for slicing only and not for encoding. Apparently it's apparently a lot trickier than I originally expected. But there might be cases where, in certain commands, arguments cannot be passed through into this way. So if we do add arguments to, if we do add arguments into our encoded commands or in our slice commands, in certain cases, it might treat that entire string as the command, and it will think, well, ls-take isn't a command. Like, on its own, it's ls and then take, so it would fail. However, we can just throw that argument to the very end, and it would work. A very similar thing happens when it comes to data piping. There are cases, in most cases, I find using an encoded pipe or encoded the greater than icon here, that would also cause the command to fail. So with that, maybe try to get the flag. I see that the link has probably gotten lost in chat, so I'm just going to bring it back down in case if anyone needs it. I'm going to give maybe about, I'm going a bit slower than expected. I'll probably give about 3 3 minutes. So I'll talk to you guys at 7:45. Cool. Just really quick, would anyone like to just work at it a little bit longer before I go into a demo, or is everyone okay with just going straight into the demo? Okay. Cool. So I'll just do that right now. Gotta just get the link real quick. Fudge. Where's my... Here it is. My oversized page. It's even more secure. So once again, we have an IP, and it's actually allowing us to enter whatever we want. It does take a bit of time, but let us do remember that you want to end the previous command. So in this case, ping. I'm going to be using backticks just because it's slightly easier to write. It's one character less. I'm going to be writing echo into the command so that it would write into standard input. So that'll be, we're going to be looking for into the root directory. So specifying the root directory first, because our command is going to be ls /. Do remember that if we're using the ref command, it's not going to reverse a backslash into a forward slash, just as a heads up. And we're switching ls into sl, because that's just what ls is backwards. We're going to pipe that into rev. And then, cool. So now we see that we have flag.txt in here. So I'm just going to go txt.galf, and then tac for cat backwards. I messed up somewhere, which is this quotation mark. Oh, sorry, I forgot to echo it. It's important to make sure that rev is receiving it through standard input. So I'm just going to throw that into echo, and then we need to specify that it's the root folder, and boom. Now we have the flag after a few misfires right there. But anyways, let's keep on going. So I just have a few final notes. There might be the case where a command is inserted into the center, the user input is inserted into the center of a command. This just might be how the command works on its own. However, putting in whatever injection might break the command entirely and prevent it from running. And to solve this, we can actually use a similar method as we do in SQL injections, which is using the comment character, which in our case is the octothorpe or pound key. The reason why this, we can see the reason why this works. Let's consider the pseudocode for the server, and it's just grepping the pattern ICMP for whichever reason. And let's consider our injection, who am I? Throwing that in, it produces the command to be ping, semicolon, so that just finishes it. Who am I? taxc5, because our ping command uses taxc5 as an option. How the issue is that when this is called, who am I doesn't have the argument taxc. So because of that, it's going to fail, and we don't get any useful information out of it. We do see that the server is command injectable, which is good, but we don't get anywhere by looking at a error message. Alternatively, we could add the bash comment character to the end of it, and it will indicate that everything after the octothorpe is a comment. So when we call it, it's going to run a failing ping command, and then the who am I. Cool. So if you're ever interested in reading more into this, here's some links. I personally really recommend reading this Windows OS command injection obfuscation link. I think it's very interesting because there's a few differences. We're mostly focused on Linux obfuscation, like command injection obfuscation, but Windows is really funny. I highly recommend that. There's also a command obfuscation detection tool that's built in Python if anyone wants to take a look at it. However, I do have one last challenge I'm going to give to you. I'm going to let you guys mess around with it and give no background on how to get the flag. Again, this website is going to be up for this entire week, but I will be giving a demo on a solution probably in about, I want to say 7 minutes. So yeah, best of luck. I'm just going to hop in for a quick hint. If you guys want it, actually, would you guys like a hint? Cool. Okay. Well, Jeremy has decided your fate, so. Wait, okay. Actual question. Is anyone able to request the server? Oh, never mind. Okay, cool. I see a thing. I just saw it like hang for a long time. Okay. Yeah. Oh, I think I know why. It's just like, okay. Yeah, I think it's just the way how I implemented it on the back end is not. I didn't consider that, and that's bad programming on my part. Cool. Just for the sake of time, I am going to go into the demo really quick. Just because it is almost 8 and I don't want to eat too much of your time. I do recommend that you try this for yourself. I think it's pretty interesting. The flag for this challenge won't be in this demo. So if you actually want to avoid yourself from getting any spoilers whatsoever, you can hop off now. There's nothing after this besides like a big slide that says thank you on it. So if you want to just go into the challenge blind, you can hop off. I won't feel bad in any way, shape, or form. But I'm going to demo a solution. Cool. Oh, it's a bit big. I'm going to minimize it a bit. So as you guys probably saw, we have this web page that's just hashing whatever we input. So if I do ASD of movie, because that's a Tomska reference, we get the SHA-256-SUM hash. And SHA-256-SUM is a Linux command. So if I go over to my terminal, the way and mess around with SHA-256-SUM, we'll see that it wants user input. So the only way to get it working is by echoing some sort of standard input. So let's say hello world, and piping that in. So that means our input is likely going into the center of the command. So we would need to use the bash comment character that I mentioned before. So doing ls tech la, for example, and running the comment command, we do see an error, and that's because this, oh no, that's because this this page is also checking for commands on the back end. No worries. Let's try doing a. I'm going to try to speedrun this. A reversed thing. So that's IMO.hw. I typed that a lot while working on this. And we'll see that it's also detecting reversed commands, which is not good for us. So let's step away from the input and let's take a look at this link. If you scroll down just a little bit, it says friends of admin. Well, let's check this out. Oh, well, now we have this little login page. we can try to enter something, but we're going to get an incorrect password because we don't know who it is. So there's no harm, no foul. Let's try to create an account. So I'm just going to name myself Petiol and give myself the password. Just so you know, this is happening on a separate server from the one you guys are working on. So I'm going to just log in. So Petiol, password. And oh man, that's very big. We see that we're not found on the whitelist. What is this whitelist? Well, the webpage tells us to add us to /whitelist and gives us this token. Well, what could this mean? I'm just going to copy this token and place it here for now. Token equals that. So that's our token. Cool. Well, if our token needs to be found in whitelist, then what happens if we just manually put it in ourselves? So let's try that. Because we looked at the echo command earlier, we know that echo is being run. So we can probably try using, what's it called? Data redirection. So let's try doing that. So let's try echoing our token, boop, and let's try putting that into /whitelist, like the page mentioned. Well, we're getting that same error. And if we look at the console, it looks like the page isn't being very verbose, but the console is. It says that the action is not allowed. Due to recent attacks, the character allowing Linux data redirection has been disallowed. That's unfortunate for us, but there's actually still ways to write to a file without using Linux data redirects. So I'm going to just do a general search. Linux append to a file without data redirection, I should say. And then we see the Stack Overflow thing that I've referenced. And then here we see quite a few options that we can take. There's the set command that we could use. I find this T command to be the most versatile on my end. So, and we see that it's also accepting user just standard input. So it works perfectly for us. So let's just try running T. And then append, whitelist. Assuming I did this correctly. Oh. It's supposed to be checking for that. Anyways, this would have failed. So what we could do instead is we could encode it in base 64. And I'm just going to run T. Sorry. Oh, sometimes my browser gets messed up. B2A is just a JavaScript function that allows you to encode strings into base 64 strings. So we can actually just run, let's just quickly echo our, sorry, we're going to be echoing this into T. So I'm going to do echo, and then actually I don't need this first one. I'm going to put in our my token and pipe that into T, but theoretically, because T is being captured, I might have messed up here. We can encode it with base 64, echo it into base 64 tac D. With some further searching, you can see that base 64 tac D also accepts standard input and can place everything onto one line. And then now this part of the command is going to get resolved to just the T command. And then I'm just gonna, that's the T command being invoked. We're gonna specify that we're appending. And then lastly, we're going to write it into whitelist. Closing that off, sending it out. And now we see our token. And with this, T just writes the standard input whatever was just written. So it looks like we're good. And if we log in, petial, and then password, because my password's garbage, we see, oh, that's not good. I'm not actually 100% sure why that's breaking now, because it should be in whitelist. Well, that's embarrassing. That should have just worked just then and there. I've been running into that quite a few times, huh? Well, anyways, that should be the steps on how to do it. I'll try to redeploy it in such a way so that if you do want to get the flag, I'll probably just make a announcement. I probably won't add anyone, so just keep an eye out. Or actually, I'll ping here. So just stay online. I'll fix the error, but it should show up if you follow these steps. Anyways, thanks for working with me through all of this. I hope you guys enjoyed. And yep, just a quick reminder, if you want to register for tomorrow's speaker series with Hack Your Learning, this one is completely free to everyone. There's the registration form is in the announcements channel. But beyond that, I hope you guys have a good night. Great. Yeah, thank you, Alex, and thanks everyone for coming to today's workshop. If there's any questions, do feel free to either message me or ping me or whatever. Yeah. Anyways, have a great rest of your day and have a great week.